Question 13c. Suppose f of x equals tan of the inverse cos of x and g of x equals the square root of 1 minus x squared all over x. The graph of y equals g of x is given. Part 1. Show that f dash of x is equal to g dash of x. F of x may be differentiated by the chain rule. So f dash of x is equal to sec squared inverse cos of x multiplied by negative 1 over the square root of 1 minus x squared. And this can be written as 1 over cos squared inverse cos of x multiplied by negative 1 over the square root of 1 minus x squared. Now cos and inverse cos are inverses of each other, so that equals 1 over x squared multiplied by negative 1 over the square root of 1 minus x squared, and multiplying the two fractions together, we get negative 1 over x squared multiplied by the square root of 1 minus x squared. Now g of x may be differentiated by the quotient rule. So we have g dash of x is equal to u dash v minus uv dash over v squared, so that's the quotient rule, where u is equal to the square root of 1 minus x squared, u dash is equal to half outside of 1 minus x squared to the power of negative half, multiplied by the derivative of what's inside the brackets, which is negative 2x. And this equals negative x outside of 1 minus x squared to the power of negative half. So rather than writing it in surd form, I've left it in index form for now. V equals x, hence v dash is equal to 1. So substituting these values for u and v and u dash and v dash in the quotient rule, we get g dash of x is equal to negative x squared multiplied by 1 minus x squared to the power of negative half. So that's the u dash v, minus uv dash, which is the square root of 1 minus x squared, over v squared, which is x squared. And this equals negative 1 over the square root of 1 minus x squared, so converting this negative index here into surd form, minus the square root of 1 minus x squared over x squared, since x squared is a common denominator for both of these terms. And that equals negative x squared minus 1 minus x squared in brackets over x squared multiplied by the square root of 1 minus x squared. So this is found by finding a common denominator. So multiplying this fraction by x squared over x squared, and this fraction by the square root of 1 minus x squared over the square root of 1 minus x squared. So we have this negative x squared and a positive x squared here, negative, negative, and they cancel. So we end up with negative 1 in the numerator over x squared multiplied by the square root of 1 minus x squared in the denominator, and that equals f dash of x as required. Part 2. Using part 1 or otherwise, show that f of x equals g of x. Given f dash of x is equal to g dash of x, and this was proven in part 1, integrating both sides, we have the integral of f dash of x dx is equal to the integral of g dash of x dx. And we get the equation tan of inverse cos of x is equal to the square root of 1 minus x squared over x plus c. Now this constant is a combined constant, so each integral will generate its own constant, but they can be combined into a single constant on one side of the equation. And we need to find the value of this constant to prove that f of x equals g of x. Now from the graph, g of x intersects with the x-axis at the point 1, 0, so that's the x-intercept of the graph. So going back to the graph there, that's this point here. So this point can be substituted into the left-hand side of the equation to find the value of the constant. Hence, the square root of 1 minus x squared over x plus c equals 0 when x equals 1. Substituting x equals 1 for x here, we get 1 minus 1 squared, so 1 minus 1 is 0, square root of 0 is 0, 0 over 1 is 0 of course, so 0 plus c equals 0, hence the constant c equals 0. Therefore, f of x equals g of x as required. The following is an alternative solution based on geometric methods. Consider tan of inverse cos of x. Now, inverse cos of x represents an angle in a right angle triangle formed by the ratio adjacent over hypotenuse. So if adjacent over hypotenuse equals x, that means the adjacent side must equal x and the hypotenuse must equal 1. And I've stated that here. Inverse cos of x is equal to inverse cos of x over 1. So AB is equal to x, AC is equal to 1. Hence, by Pythagoras' theorem, side BC is equal to the square root of 1 minus x squared. Therefore, f of x equals tan of inverse cos of x, which equals BC over AB, that's opposite over adjacent, which equals to the square root of 1 minus x squared over x, which equals g of x. Therefore, f of x equals g of x as required.